Okay. Having a test this week. I call the test the major quiz. You see it in your syllabus and you see how it's weighted. Okay. You can count as half a test or count as a whole test. Okay. So if you score on this test, much as it does, if it doesn't include the trick. Okay. Now, there's some questions. So let me answer the question before we go on. At least one person took it already. If you want to. Okay. Because I told you how the test is generated. There are 4 problems and you know exactly what's going to be on them. You just don't know what the numbers are. There are 3 problems where you know exactly what's on. And then there's 1 problem that might be any one of 3 problems that you know is on there, but you don't know what number. And on the 3 problems that are on there, you don't know what function. Okay. It could be the quadratic, exponential, or inverse, reciprocal. Okay. So you got to know how to construct all those graphs, use the equations, and a couple of other things that you know if you delved into the email I sent over the weekend. Okay. I didn't send it until Saturday. I told you I'd have that by Thursday, but it just turned out to be a lot of bugs. And also, I signed up for internet from a provider who came out and installed it and disconnected my phone. And then did some really bad things. So we just canceled them. But we don't have but we got our cell phones. I'm not going to mention the provider because I don't use class as a forum to tell you who to stay away from. Okay. But yeah, there are 4 or 5 providers around. It was one of them. Okay. Anyhow, that's what was going on, and that's what took me till Saturday to get this done. And I do apologize for that. The test will be available all this week. I'll even accept it anytime before class a week from today. Okay? If you took it and want to take another one, okay. I'll take the better. Okay, if you get in there and just forget everything, go home and learn it. And then come back and take another one. You know, put some more in. Fair enough? That's more than fair. Again, it counts the way it says for the major quiz in the syllabus. Okay. Yeah. And some, but I'm going to work them quickly because we worked them slowly many times already in class. So if you've been doing what we have been doing in class, you've done all this. Or if you've seen it done and taken notes and had the opportunity to go take a look at the video again. Okay. So lots of things. Also, you know, there's only one open math assignment due between now and your next class. Okay. So you want to get that one done. It's a big assignment. I mean, it's an important assignment. And we'll talk a little bit about that. We've already talked about a good bit of it. Okay. So I'm taking version 1 of the document. I told you how the test is going to be. You're going to have a version 1 problem, whether it's quadratic, exponential, or reciprocal. Well, I can't do all three. They have to be able to draw the graph to do it, okay? And I'm gonna pick the one that's probably the last one we did, the reciprocal shape. Of course, if I do, I'm gonna do the quadratic shape. You just have to know how to do the shapes and answer the questions. Process is identical. Details differ with the function and with the numbers I give you. Okay? Or I didn't give you the numbers. I told the program, I gave them the rule for selecting numbers, but they're random. Okay? Okay, so if you have this in your email, you might want to follow along. If you have that email, you can open that document and read the problems. Because I'm not going to be able to write out the problems on the board. Okay? So I'll give you a minute to do that if you want to. Because some people are reaching for their phones, and I kind of recommend it so you can see what the problem looks like and you can see what the solution looks like. You might learn it faster than you would if you had to go home and look at the video along with the problems, okay? Okay, giving you a chance to. Okay, anyway, we had a little trouble. It appears that some software is perfectly capable of representing an HTML file, automatically opens it as a text file, which has a lot of stuff that kind of gets in the way of reading it, and the formatting isn't there. Okay, now we need to move. Okay, so quadratic shape in a 4x4 rectangle with a red dot at the point 2024. Okay, so ouch. It's a 4x4, so we know we have a rectangle. So I could have drawn that a little bigger, but we'll live with it. The red dot is at the point 2024. It's quadratic, so the red dot is here at the center of the lower edge. That's the way it's defined. Read the words. Okay. So this is x equals 20 because it's at point 2024. And this is y equals 24. It's a 4x4 rectangle. 24 and 4 gives you 28. So this has to be y equals 28. Half of 4 is 2. So this is 2 units to the right. This is 2 units to the left of x equals 20. So there's x equals 18 and x equals 22. And now we construct the shape. Well, we do our subdivisions. Our last little line so we can skip it. And I'm not going over the details here. If you don't know how to do a type 1, type 2, or type 3 graph, and which one goes with which function, make sure you do by the time you take the test. Went too far there. So there are construction points. And there's a reasonably good graph of the function. We label some more lines. Here's y equals 24. I'm not going to label them all. You should be able to label them all, but I'll label x equals 19, x equals 21, y equals 24, y equals 22, y equals, whoa. That's y equals 26, y equals 25, and y equals 24 and a half. It's kind of small, but you know how to label those, so you make it table. X values are 18, 19, I didn't label it, but you got 19 and a half, you got 20, you got 20 and a half, 21 and 22. Your Y coordinates are 28, 25, 24 and a quarter, 24, 24 and a quarter, 25 and 28. Then I say the function is the graph of y equals x squared. Well, I give you the function. Okay. And then you're gonna do y equals x minus 20 squared plus 24. I didn't leave myself enough room, which wasn't real bright, but you know what I wrote there, it's this. And you get then 18 minus 20 squared plus 24 equals, I'm not going to do the arithmetic. You do the arithmetic. You just plug in the numbers, then you do 19 minus 20 squared plus 24 equals, and you fill in the details. Show me that this is 2 squared plus 24, and that does equal 28, right? And 19 minus 20 is -1. You square that and add 20. I want to see the details of the arithmetic. I'm not going to take time today to do them. You've seen me do it a number of times. You understand, hopefully, what I mean by show me the details. I want to see that you're doing the arithmetic and not just writing down these numbers, because if you write this down and then write down equals this number and it isn't right, there'll be a major penalty. Okay? So do it honestly. Better to screw up the calculation, say, oh, that didn't equal, what happened? Okay? Than to fake it. Okay? Don't fake the calculations. Okay, estimate the value of G of 25.8. Okay, well, G of 25.8, we come over to 25.8. So well, that's a problem. Because 25.8 isn't in here. So there's a bug in my program. So I'm going to have to go fix that. I'll pen in some right numbers. Okay. Big pain. So let's just say instead of 25.8, it's 21.8. And this is G of X. So this is X equals 21.8. That's this line. And that's a little low, but we would estimate then Y is between 26 and 28, a little closer to 28. So I'll say 27.2. You've seen me do that a number of times. Then calculate G of 21.8. Okay, well, that's easy to calculate. 21.8 minus 20 is 1.8. Square 1.8, you get 3. make that into an honest 3.24 plus 24 equals 27.24. So my 27.2 miraculously came out really close to 27.24. My graph wasn't that accurate. Okay, my positioning of this line wasn't all that accurate, but somehow I still came out really close. Okay, it doesn't have to be that close as long as it's reasonable. If I'd estimated 27 or 27.5, I might have said, I think it's a little lower than that, but okay. Just want to say that you know how to make an estimate. If you estimate that as being 13.6, it's not between 24 and 28. I know that either you had some kind of a cosmic particle obliterate part of your brain for 10 seconds, or you don't know what you're doing. Okay, or something in between. Okay. Kind of like, my program, I know what it did. I know what the line in the program is. And go back and fix it and reprint all these, but I'm just going to take the easy route. I'll just pen in a better number there. Okay. And I don't know, that might repeat on all the problems. Now, the first problem will be asking exactly the same things, but maybe for the exponential and maybe for the reciprocal. Okay. I even double check that. I don't know what's in there. I used a Y calculation for X and whatever. Okay, then use a graph to solve the equation X minus 20 squared plus 24 is 27.6. Well, that means I'm going to want to draw the line a little higher than that. Y equals 27.6. Sketch this. I want to see those lines and I want to see them labeled. X approximately equals what? I would say that's 20.9. Now, one thing I didn't ask I could have is plug that back into your formula and see how close you get. Be reasonably close, but I didn't ask you to do that. Okay. Because I don't want the test to be too long, and I think you can do that pretty easily. But next time I ask a question like this in the test, I might well, so it's kind of worth thinking about that. Then sketch the fundamental triangle for the interval. I did that right, 20 plus 8, 20 plus 1.4. Okay, well, where's 20.8? Okay, here is X equals 20, here's X equals 21, and 20.8 would be about equals 20.8 would be about here. And then 21.4 would be about here. And do like I did, make bigger graphs so you can do this. Fundamental triangle that I defined last time is just a triangle. You get this point and this point. When you go straight over with an arrow and straight up with an arrow. So you might want to review what I told you in class last time. Now, I think I've said, I don't say it here. I don't think. Nope. And now here's the fundamental triangle, which I abbreviate by FT. Now, I can make a bigger fundamental triangle over here. Noting that this is on the line with x equals 20.8. And this is on the line x equals 21.4. I can estimate my y values. This is 24 and a half. So this would be about 24.6 or 24.7. And use a little kind of wavy equal sign when you're working with an estimate. I won't count off if you don't, but it's a good habit. Okay. And then this looks like, my y equals 26 line dips down a little bit here. So I'm going to say y equals 25. It's from 20.8 to 21.4. Fingers, 20.8, 20.9, 21, 21.1, 21.2, 21.3, 21.4. Okay, but you want to do a subtraction. So you would label this run equals 21.4 minus 20.8 equals, I'm going to write 0.6 just so it's clear what the number is. If you just write 0.6, that's okay. That's what a computer will usually do. They won't put the zero on it. Okay, understand what I just did? Told you what the run is. I told you how long this arrow is. That's 0.6 because it's this minus this. This is a rise. It's obvious what I mean by run and rise. Right? And the rise equals 25.8. Then slope is rise over run. That's 1.2 over 0.6 equals 2. And I put a rectangular box around that 2 and put it next to the actual straight line from this point to this point. It should also make sense of one of the homework problems people tended to make mistakes on. Okay? Not everybody did the homework. You really ought to go back and I think that homework is in this class. I'm not even sure it's from this class. Okay? Might have been for the support class, which is doing a slightly easier version of what we're doing here. But working ahead a little bit so that I understand it when I see it here. Okay. There's your fundamental try. Now I said make a table of the construction points. Note is in 2 sides. Find the average rate of change on the interval 18.2, 18.3. Well, that's the change in your Y value divided by the change in your X value. I wrote that out last time. Change of that with respect to change in this or whatever. You take how much your Y value changes and divide by how much your X value changes, which is exactly what we did here. But this is based on a graph estimate, okay? The graph estimate told me that Y changed from 24.6 to 25.8. So my change in Y was this. So I could even identify this as an example of a delta Y. And the run is a delta X. A change in the X value, a change in the Y value. Okay, well, to get the change in the Y value, you got to plug 18.2 into the formula. If you plug 18.2 into the formula, think actually we did something very much like that. You're actually going to get the same thing you got for 21 point. No, we don't. Okay. Anyhow, you plug in 18.2 and you subtract 20, you get 1.8, and you get 3.24 plus 24. Why is that symmetric? Exactly the same thing here. So I'm going to write this. You don't have 0.3 minus G evaluated at 18.2 divided by 18.3 minus 18.2. Getting a little crowded here. And when I say G of 18.3, we calculate just the way we calculated the numbers on the table and the number here. Now, just for the randomized numbers, G of 18.3 turns out to be the same as G of 21.8 because 21.8 is 1.8 units to the right of the middle and 18.2 is 1.8 units to the left of the middle. It's just a symmetrical nature of the function. You don't need to know that. That's probably not going to happen on the problem you get. But anyhow, that's going to equal 27.24 minus, I'm sorry, it's 18.3. 18.2 would be 27.2. A G of 18.2 would be the same as G of 21.8. G of 18.3, you're going to have 1.7, 2.89. So you're going to get make sure. Okay, it's going to be 26.89 minus 27.24. I think those numbers are probably right. And the difference here is 0.1. Well, we subtract this and we get 0.35. Get negative 3.5. Okay. Now that would correspond to a fundamental triangle. Just want to visualize where it is. 18.2 would be like here, and 18.3 would be like here. So there's a little fundamental triangle up there that would correspond to this calculation. But you don't want to make that fundamental triangle. But I'm pointing out that it's the same result you would get if you did, but with calculations. Okay, then it asks you to do the same thing on the interval from 18.2 to 18.21, which would be a tinier fundamental triangle. Okay? The hypotenuse of that triangle would go along the same curve. So the number you get would be pretty close to this. Now, let me tell you how we grade this problem. Okay? If this problem is worth, let's say I haven't decided how much it's worth, but let's just say it's worth 20 points. I think it's going to be worth more than that. I'll tell you a little bit more about that a little bit later. It's worth 20 points. Drawing the grid correctly would be worth 5 points by itself. Drawing the points, making the table would be worth another 5 points. Plugging in the calculation, validate the table, would be probably about another 3 points because I want to leave some points for the rest of it. But at that point, you're already passing as far as this problem is concerned. Okay. So all the rest of the stuff I've done here is worth 7 points. Well, that's like the difference between a C and an A. So don't blow it off because it's not hard. If you think about what's going on and understand what we've already done, make that estimate. You're good at that. That's a couple more points. Getting you up almost close to the B. Okay, you get that much. You don't know how to do any of this other stuff? Well, labeling a fundamental triangle is probably worth another 3 points. And if you get that much, you got an A on that problem. You got 18 points out of 20. Does that make sense? And then the last 2 points is being able to calculate this average rate of change. Nothing that we've done here is difficult if you practice. It's just step by step. Make your grid. Of course, you got to know what grid goes with what function. And you got to do it right. If your grid isn't right, you don't get those 5 points. Plot your points, make your table, etc. One step at a time. All right. Okay, now this, what I sent out also has a 1B and a 1C. They probably have similar errors on that one number, but I can go in there and change one digit in the number. I'll just use a pen. And I'll do that here in a little while. All right. Problem. I'm going to do the most important ones first, the most valuable. I'll go to problem 4. Fundamental triangle. You don't have to do much work. I give you the 2 points. That's all I give you. You don't have to calculate a function. You don't have to do anything fancy. You just have 2 points. So the point 1, 2. Well, we like to maybe draw an X and a Y axis, but not necessary. 1, 2, and 7, 5. Okay. I'm going to put X equals 7 out here, and then X equals 1 is probably about here. And then, it's not X equals 7, it's X equals, it is, it's X equals 7, I don't know what I'm doing. And then we got Y equals 2. And y equals 5. So the point 1, 2 is where the x equals 1 line meets the y equals 2 line. And 7, 5 is where the x equals 7 line and the y equals 5 line meet. There we have a straight line between the points, because that's the first part of the fundamental triangle. And then we have the run, which is indicated by an arrow to the right, from the leftmost to the rightmost point, and the rise. And then we label it. The rise is 5 minus 2, which is 3. The run is just 7 minus 1, which is 6. So the slope equals rise divided by run equals 3 over 6, which reduces to 1/2. And we put that 1/2 here and put the rectangle around it. Exactly the same steps I used in doing the fundamental triangle on that first problem, but in a much simpler context where I just give you the 2 points. On the first problem, you got to get the 2 points either by estimating them or by calculating them, but I give you the formula. Okay, so none of that is difficult. But right there is fundamental triangle. I want to see all this. I see rise, this minus this equals this. The run is this minus this equals this. The slope is rise over run equals what I got here for the rise, what I got here for the run equals lowest terms in box next to the. Okay. I want to see all that. If this is a 10-point problem, well, you can kind of see what the points are. At first, I want to see decent triangle with the arrows. Okay. Then I want to see calculation of rise and run. Then I want to see calculation of slope, and I want to see the rise over run there, and then the numbers and so forth. So it's like 5 steps, 2 points per step or something like that. Okay. That's 4A. 4B isn't exactly the same as 4A. Now, problems 1A, 1B, and 1C are exactly the same thing, just for different functions. Problem 1 was for quadratic, problem 2 would be an exponential, problem 3 would be reciprocal. All right, 4B says the same thing, except goes into a little more detail. So 4B is actually a little more involved than 4A, meaning I'm probably going to grade it a little more leniently than I grade 4A, because some people are going to get 4A and some people are going to get 4B. But I say f of 6 equals 1, f of 9 equals 5. It's a change in f divided by the change in x. Okay, well, f has value 1, then it has value 5. And we could even say y equals. So the change in f is really a change in y. So y goes from 1 to 5. It doesn't even hurt to sketch this information on a graph, although it's not required. Okay, so here's X equals 6. Here's X equals 9. It can be very helpful to sketch this so you really understand what the information is telling you. So I do recommend that you sketch it, but I'm not going to grade that. And then Y goes from 1 to 5. So we got Y equals 1, Y equals 5. And then you can sketch your fundamental triangle and all that stuff. And you get the rise is 4 and the run is 3. So the slope is 4 over 3. And that is your rate of change. Okay, your average rate of change. Now the formula is change in F over change in X. It's 5 minus 1 over 9 minus 6, which is 4 over 3. If you know what this means, and again, it means just what I sketched on the graph here. If you know it's a change in Y, which is also change in F, because F equals Y. Change in F values are 1 and 5, so it's going to be 5 minus 1. X values are 6 and 9, so it's going to be 9 minus 6. So this is as easy as that if you know what the notation means. And there's a 50-50, you are going to get a problem 4. So you'll either get one like this or one like this. This is easier. I'm a little more forgiving when I grade this one because it's a little hard. Okay. But do it so you don't need forgiveness. Just do it right. That's how it's done. Now the second part is an interpretation. And for this interpretation, it's like you got a metal rod with the end stuck in a block of ice. The closer you are to the end, the colder it is, right? Grab the metal. Here, it's colder than it is here. Okay. Here is colder than here if the ice is over there. And it gets colder as you approach the ice. That's the interpretation. Then what does f of 6 equal 1? Well, I'm writing this pretty small, but I just said y equals f of x is temperature, x is distance. So this says, well, show me the number that gives you the temperature here. Show me with your fingers. Okay, so let's see. So y equals f of x is a temperature. This says f of x equal f of 6 equals 1. That's f. So the temperature is 1. Somebody wanted to say 6. That's easy to do. I mean, it's easy to get it confused. It's a little ambiguous, which is why I'm talking about it. It's not ambiguous, but it's a little hard to interpret. Okay? So x is 6. Y is 1. So x is temperature. Yep. X is distance. Y is temperature. So 1 inch And temperature, it's not 1 inch. See, I'm doing it really easy if you do it without thinking, so make sure you think. So 6 inches from the end, and it would help if you said X is 6 inches and Y is 1 degree. And 9 inches from the end. Temperature is 5 degrees. That would be your interpretation of this information. Now, we haven't done all that much with interpretation, so I'm not going to penalize that part, but it's worth 3 extra points. Okay? 3 points of extra credit, and it's not difficult. Okay? If you keep your wits about you and think about what the graph is telling you. Now, we're going to try to get much better at that as the class goes on. We haven't spent as much time on that as I would like to have because we had to spend time on other stuff. But we're going to be spending a lot of time on interpretation because that's really why we do these things. Okay? And that's what really I think is going to be one of the main benefits of this course for you. All right. Get the idea? That's how you do problem 4. That's 4A, that's 4B. And not everybody gets 4B, so not everybody gets those 3 extra points. Okay. Now say this, if you want to go to 4A and put an interpretation on this, go temperature and distance, could be money and hours. Okay. I give you 3 extra points, but that's not going to be stated on the test. Make sense? So if you do an interpretation, give me the details of an interpretation on this one. It would be worth extra points, but I recommend you go on and get all the other problems done. If that's not real obvious to you, don't sit there puzzling over the interpretation. Picture's trying to commit suicide, laying down on its side, laying down flat, wait for me to step on it. Okay. Now, number 6. Another thing I'll tell you, whatever function you get in number 1, you're going to have a different function on number 6. So you have to graph at least 2 of the 3 functions that we've focused on, okay? So I'm going to do 1B or 6B, okay? So this is toolkit exponential function. It's the exponential shape angle. red dot at 0, 0. The basic quadratic function, just replace exponential with quadratic, still in a 4x4 rectangle, and the red dot is at 0, 0. Okay. For every basic toolkit function, the red dot is at 0, 0. Then you have to shift it to move it. And we've talked about that, and we're going to talk about that a lot next week. Okay. All right. So that's the first thing you need to understand, is what I mean by the basic function. And for all the three functions that we've looked at so far, it's always a 4x4 rectangle. When you get to the cubing function, that changes. Okay. And there are 5 really important functions. We'll see the other 2. You've already seen them when you did you did like 10 of them, but we haven't talked about constructing. Okay. The fourth one is a reciprocal square function, which is also in 4x4 rectangle with the origin to a cubic function, a little different. All right, so we have this. So we draw it. Well, 4x4 box with red dot at the origin. That means that this is x equals 0. This is y equals 0. This is x equals 4. This is x equals 2. This is x equals -2. And that's it. We go ahead and do the construction. 1, 2, 3, 4 lines for the middle, halfway between the middle and each. The left edge, not at the lower quarter. Lower quarter is a major penalty. To left edge, then over 1 up, 1 over 1 up, 1 over 1 up, 1 over 1 up, 1. Easiest one to draw, as long as you remember, left edge, lowest construction line, 4 construction lines by the halfway thing. Okay. Now, there it is. Everybody can draw it. Everybody is doing a pretty good job with these. Just be sure you got all the details right when you draw these. Know the rules. Okay, now I say we want the average rate of change on the interval from -1 to 1. Okay. Well, that means our interval goes from x equals -1 to x equals 1. So here's our interval of the x-axis, and we don't have to draw that in, but it helps to see it, because then we're going to go from the graph point at this end to the graph point at this end. Make sense? And then we can get the average rate of change. But I want you to depict it with a fundamental triangle. Well, it's the 3rd time you've seen a fundamental triangle, so you're probably getting sick of it, but we'll draw it anyway. So from this point to this point, again, it's the toolkit exponential shape, 4x4, red dot at the origin, draw the shape, label the graph. Okay. Average rate of change on the interval from -1 to 1 means the average rate of change from the x equals -1 point to the x equals 1 point on the graph. There they are. Now we draw a straight line from point to point, and then we draw an arrow this way and an arrow this way. Okay. Now, I'm going to do kind of outline labeling because I don't have room to write rise equals, run equals, and letters that you'd be able to read. I'll draw a bigger one because that's standard. If you draw too small of a graph to label it properly, just pull that triangle out, as I will do. So here's the rise, which is what? Well, you probably will have labeled your y's, and y is equal to 2 here, y is equal to 1, y is equal to 1/2, and down here, y is equal to 1/4. So y goes from what to what? Well, I'm on the line y equals 1/2, and I'm going up to the line y equals 2. You want to calculate it. You want to say the rise equals okay, even that's a little hard to read because I put these labels over here. Okay. You have labeled these. So your rise, this arrow is going to go from 1/2 up to 2. So the rise is 2 minus 1/2 equals 3/2. The run goes from x equals -1 to x equals 1. So the run is one minus -1, where you end up minus where you start, and that's equal to 2. Now let's draw that a little bigger so we can actually label it. Get some meanings. I recommend you write rise equals delta y, just to remind yourself that that's a change in the y coordinate. But I don't require that. Just rise equals 2 minus 1/2 equals 3/2. It is helpful, I'm not going to require it, but it is helpful to remind yourself that the coordinates at this point are 1, 3/2. No, they aren't 1, 3/2. This point is 1, 2, and this point is -1, 1/2. By reconciling with the coordinates of the points, you're doing the 2 minus the 1/2, the y coordinate minus the y coordinate. That's a lot like the formula that gives you y2 minus y1, okay? For the rise. But there's your rise, and your run equals 1 minus -1 which is 2. Now you can see, you can count on your fingers from -1 to 1. -1, then you get 0, 1. It's 1, 2 units. This could be seen as 3½ units, but we write the calculations out because many times you're going to have big unfamiliar numbers when you're trying to do different applications. Okay, so now we say the slope equals drives over run equals 3½ over 2. Which equals 3½ times 1/2. It's 3½ divided by 2. You divide by 2, you multiply by 1/2, and that gives you 3/4. And I do want to see fractions done right. So there's the slope. And I do tell you on this problem that if the fundamental triangle isn't big enough to label, draw a bigger one and label it. We want all those aspects of the label that represent everything you did to calculate the slope, all in one place, so you can see if you made an error. If something comes out haywire later, you don't have to go back to a page of incoherently arranged calculations. You got one picture. Okay? And you know what every part of that picture means and how it was obtained. Fair enough? Okay, well now, those 3 problems, one way or another, will be 60%, maybe even 2/3, which would be 66.7% or whatever, 67% if you round it off, of your total score. Okay? Meaning if you just got those 3 problems completely right, you would have a pretty strong C. All right? You know, maybe I'm lying to you because it'll actually be more than 67%. Might even be as much as 90%. So you almost make an A just by doing these 3 problems right. Probably not quite 90%, so I don't want to give you an A unless you can do that 4th problem that's on the test. Now, the 4th problem on the test will be one of the ones that I didn't go over, number 3, number 2, number 3, or number 5. And we might not have time to go over all of them today, but we will have plenty of time next time. Also, we'll have time. I have to take some time to talk about composite functions, I think, because that'll be your assignment for Monday. But we should have ample time to discuss any aspect of what I've talked about here that you're uncertain of. Okay? Answer questions as well as anything we don't get done, but I think we'll get a couple of these done in the time we have. So number 2, just ask you to make a graph and state the domain and range. Trying to find So I give you one of the functions. And let's do the reciprocal shape. This would be like 2c. And I think this is a 4x4 grid. I don't want to get too tricky on you. But it's the reciprocal shape, so the red dot is in the middle. And let me make sure, it's not a 4x4. Yeah, I think it is a 4x4. Maybe not. I've got to find it again. No, I gave you all kinds of weird dimensions, sorry. Okay. You could get 24/32 with the red dot at the point 816. So you should be able to construct that. But that could be a little bit of a curveball. So let's make sure the red dot is at x equals 8, y equals 16. So we know this line is x equals 8. And this line is y equals 16. We know it's 24 units high. So I'm going to just draw a couple of arrows, distance arrow here. It's 24 units. And it's 32 units wide. So what does x equal on this side? What does x equal on this side? Well, this distance is half of 32, so this distance is 16. Meaning x equals 8 plus 16. So x is 24 over here. Over here, x would be 8 minus 16 equals -8. From -8 to 24, how far is it? Well, from -8 to 0 is 8 units, and from 8 to 24, or from 0 to 24 is 24 units, so you got 32 units, right? Or 24 subtract -8, you get 32. That's the first time we've used negative numbers, but they can occur. So I wanted to make sure you see what to do. That wasn't music, was it? If it's music, I automatically start dancing. And then you never want to look at anything again in your life. Okay, now, so there's a warning. That happens. Okay, so you got 24 units here, meaning it's half of 24 from here to here, half of 24 from here to here. So that means y equals 16 plus 12 equals 28 up at the top. And y equals 16 minus 12 equals 4 down at the bottom. Everybody understand that? It's just basic arithmetic, basic coordinate plane. And if you're having trouble with it, let me know. Okay. Well, then we're going to construct the reciprocal graph. I've already gone into details about the boundaries and the red dot and stuff, but often the first thing you'll do is you'll just sketch the grid. The reciprocal graph, it's a type 3 grid. So you do this thing with vertical lines and not very well positioned, but we'll deal with it. Okay. And then you do the same thing with horizontal lines, just where you went halfway from the right edge to the middle, you go halfway from the bottom to the middle. And you went halfway from that line to the middle, you go halfway from that line to the middle. And people are doing pretty well in class with this graph, just to reinforce it. And then halfway from the left edge to the middle gave you this line. Well, halfway from the top to the middle gives you this line. And then halfway from that line to the middle gave you this line. Halfway from here to the middle gives you this line. Now it's 24 units from here to here, meaning it's 12 units from here to here. Well, we already labeled this as y equals 16, so we know that 16 minus 4 is 12. That's 12 units, right? Now, it's half that far from here to here. Half of 12 is 6, so it's 6 units from here to here. That's y equals 10. And you can check from 4 to 10, it's 6 units. From 10 to 16 is 6 units. So this is in the middle, so it's consistent with your construction. And then halfway between 10 and 16 is 13. And of course, we could have found the 10 by doing 4 plus 16 divided by 2. Halfway between two numbers is always add them, divide. Half of that is 22. So the line half. Then halfway between 16 and 22 is, well, 16, 22 is 38. Half of that is 19. You can do all kinds of consistency checks. How far apart are these lines? They're 3 units apart, 10 to 13, right? How far apart are these lines? 13 to 16, well, that's 3 units. How far apart are these lines? Well, that goes from 16 to 19, that's 3 units. How far apart are these lines? That's from 19 to 22, that's 3 units. So getting redundant. And how far is it from this line to this line? Well, that's 22 up to 28, that's 6 units. But that is supposed to be twice as much as either of these because this is equal to this. Well, anyhow, you go and do the same thing over here and you get the line x equals 16, the line x equals 12, the line x equals 0, the line x equals 4. So there we have labels for everything. Now I don't know what I did with the paper because I want to be sure I'm answering the same question that gets asked. Looking for 2B. And I kept getting not 2B. 2B or not 2B. No, I'm doing 2C. Doggone, there is no 2C. See, we never have to do the reciprocal graph. We'll do it anyway. Okay. Why didn't I have the reciprocal graph? Or maybe 2A is the reciprocal graph. 2A is the reciprocal graph, so I'm doing 2A. I left the quadratic graph off of this because it has the simplest domain. There's no catch to the domain. Okay, so we sketch the graph. Everybody should know the rule. Now, what's the domain? Well, the domain is the x values that go from here to here. This point is included. This point is included. Why? This has to be part of the domain because there's a point on the curve everywhere above this point, right? And then this is the other part of the domain, because there's a point above every one of these, of the points on this interval. So the domain, we did this in class, I think, for this function. The domain is from this x value, which is -8, to this x value, which is 4. Union, from this point to this point, that's x equals 12 to x equals 24. Now that's a domain as graphed. The domain of the whole reciprocal function continues on to -infinity here and on to infinity here, and approaches but does not reach the line x equals 8 here and here. And that would be the whole reciprocal function, but this is the reciprocal function that you graphed. This is the picture you have. This is the domain corresponds to this picture. Range consists of all the y values that appear in this graph. And those y values go from here to here. A label kind of here. Okay. So from here to here, we've always got a y value, but no y values between here and here. And then here. Range goes from here to here, which is 4 is 13. Union from here to here, that's 19 up to 28. That's it. The reciprocal function. You do something similar for the exponential function. Just got to be careful that you know what domain and range mean. Okay. Now there are two other problems that we need to look at, 5 and 3. So you might want to look at those problems and see how well you understand them, see if you understand everything, because you'll understand what I tell you better if you've already thought about the problems. Okay.